Good day, viewers. You are welcome. How to solve these nice functional equations for p of 0. So I'll be solving this in two different ways. Let's start by solutions. Here we have p of 6x minus 1 over x minus 7 equals x to the power of 2. So we consider the first method. We have p of 6x minus 1 over x minus 7 equals x squared. First is the value of x here is not equals 7, and all other x are members of real number. Then, so suppose we let 6x minus 1 over x minus 7 equals t, and we divide this 1 by over 1, then we are going to cross multiply. By cross multiplying, we are trying to make x the subject of the formula. Then we cross multiply, we have x minus 7 multiplied by t equals 6x minus 1. And by opening this parenthesis, because there is still x in this bracket and there is still x here as well, so which we have to combine together. So let's multiply this x with t. We have xt minus 7 times t, that is 7t, equals 6x minus 1. Then we have to move 6x to this left hand side. We have xt, then when it's coming here, it was plus, then it changed to minus. Minus 6x equals, also we have this 7t in minus here. When it moves to other side, it changes to positive. That gives us plus 7t, then minus 1. So the next step, we have to factor out x. By taking out x, we have t minus 6 equals 7t minus 1. So let's divide both sides by t minus 6. So here is also t minus 6. So when t minus 6 cancelled t minus 6, we have x equals 7t minus 1 divided by t minus 6. So this is what we have for x. Then we are going to substitute back into the given function. Then we find the value of f of p of 0. So then we have p of, instead of 6x minus 1 over x minus 7, we change everything here to t. Then equals, also x, we have make x the subject of the formula, and everything gives us 7t minus 1 divided by t minus 6, then all raised to the power of 2. So this all out for p of t, and let's change t to x. We have p of x equals 7x minus 1 over x minus 6, all raised to the power of 2. So where this x here is not equal 6, but since we are asked to find a particular point in this domain, which is x is a member of real number. So at the point we are asked to find in this real space is when x equals 0. So at x equals to 0, so we are going to have p of 0. So this equals 7 into bracket of 0 minus 1 divided by 0 minus 6, then all raised to the power of 2. And when we expand further, we are going to have P of 0 equals 7 times 0, that is 0 minus 1, divided by 0 minus 6, all raised to the power of 2. So next we have P of 0 equals, so 0 minus 1, that gives us minus 1 over 0 minus 6, that is minus 6, all raised to the power of 2. And minus cancelled minus, so we have 1 over 6 raised to the power of 2. And by rule of exponent, we are going to have P of 0 equals 1 we take squared and 6 we also take squared. So 1 squared is 1 and 6 squared is 36. So therefore P of 0, it gives us 1 divided by 36. So here is the final answer for P of 0. But this method might seem long, and we can just reduce it by considering another beautiful method. And if you are just coming to this channel, please do well to like, share and subscribe. Let's get into the second method. Instead of considering all those long methods, so since we need P of 0, we just say in the second method, we're still going to let the whole of 6x minus 1 over x minus 7 to be equals 0 this time around. And to make x the subject of the formula, so we are going to have P of 0 then equals x raised to the power of 2. But we need the value of x. So to get x, we come back to this step and cross multiply. Cross multiplying, we have 6x minus 1 equals 0 multiplied by 0 minus 7, x minus 7. Then all this one becomes 0, and we have 6x minus 1 equals 0. And by adding 1 to both sides, we have 6x equals 1. Then dividing both sides by 6, this cancels this, and we have x equals 1 over 6. So if x equals 1 over 6, then we are going to replace this x with 1 divided by 6. And just as simple as that, we have P of 0 equals 1 over 6 raised to power 2, which equals 1 divided by 36. So this is more simpler than the first one. Thanks for watching and see you in the next video. Never stop learning. Bye bye.